Are you ready for DAX? I think it's time to start. DAX is the formula language of Power Pivot, and as you will see is very similar to the Excel formula language, something that you already know very well. So we will see some new function, some new concept, and we will start creating the first measures in DAX. Let's go! DAX is the programming language of Power Pivot. It resembles the Excel formula language, but it has very important differences. For example, in Excel, you are used to direct reference cells in your worksheets, like writing A1 plus B2, something like that. In DAX, you can only use tables and references to columns of the tables. In fact, this syntax is much more similar to the Excel syntax using tables. So the best way to understand these differences is looking at the same calculation created in three different ways. First, we will see the calculation in Excel using direct references to cells. Then we will see the same calculation in Excel but using tables. And finally, we will see the calculation in DAX. As an example, we will create in this workbook a simple calculation that evaluates the margin percentage for each row of the data that you see. The formula that we create contains direct references to single cell in the workbook. So when you click on F3 or E3, you see that the coordinates are copied in the formula. When you complete the formula, you can change the format so that you display the number as a percentage instead of a decimal number. Once you complete this step, you can copy and paste the formula in all the rows. Copying the cell, in reality you copied the formula, and Excel automatically renamed the row number in each formula. In this way you have a different value for each row. Now we will transform this calculation into a table calculation in Excel. The first step is transforming this area into a table. Once we have a table, we create a column, and this column will contain the margin percentage. By performing the same operation for writing the formula calculating the sales amount minus the product standard cost, this time you see in the Excel formula the name of the column and not the cell reference that you have seen before. This time you will obtain the same number, and copying this formula in all the other rows of the table, you will obtain a different value for each row. After performing this operation, we will change the format of the column G so that we will display this value as a percentage. Once you complete this step, you can see that each row has a different value, but always the same formula, because we reference the column names in the table and not the cell that are different for each row, because you will have different row number. Now, even if we have the same formula in every row, you can still edit each single cell in a table in Excel. For example, you can write 45 in a cell replacing the existing formula, and you change the value only for that cell. You can also type a string in another cell, like for example this test, that is replacing the formula only for that cell in this table. Remember, this is possible only in Excel, because in Power Pivot you cannot change the formula in a column and you have the same formula for all the rows in a certain column. Now we can create the same calculation in Power Pivot. This data model has the same table that you have seen before in Excel. We're going to create the margin formula in a new calculated column. The syntax of DAX that you have to use to reference a column is putting the name of the table, sales, and the name of the column between square brackets, like sales amount and total product cost. We divide the difference between sales amount and total product cost by sales amount, and we obtain the result that we format as a percentage, renaming the column as margin percentage. The data type of the column that we created has been automatically inferred as a decimal number. In fact, we just changed the format visualization to a percentage. The formula of this calculated column is used for all the rows of this table, so you cannot change a single value in a cell of this column. You have to keep the same formula for all the rows. The value of margin percentage column will change when we will have a different value in total product cost or sales amount. The data type of a calculated column is automatically inferred from the expression of the calculated column itself. For example, if you type a string in a calculated column, like the constant 12, you see that this number is in reality a string and the data type is text. If you use a string concatenation operation with the ampersand operator between two strings, you will still obtain a string as a data type in the result of this calculated column. It is important to note that the ampersand operator always returns a string. In fact, if we change the values passed to the ampersand operator and we use two numbers, 12 and 34, we see that the result is always the same, is a text and contains the string 1, 2, 3, 4. By using a different operator, we can obtain a different data type in the result. For example, the plus operator sums two numbers, and we see that the result here is an integer, a whole number, and the result is 46. Now, if we change the arguments and we use 1, 2, and 3, 4 as a string, the result is still 46. So the arguments of each operator are automatically converted into the data type that is required for a particular operation. However, you can see that in this case the data type is not an integer but a decimal number. And the reason is that the plus operator converts a string into a decimal number by default, but you can always force the data type to whole number for this column in order to store the result in an integer value. Every column in a table has its own data type, and for example the columns unit price, total product cost and sales amount are of data type currency. This means that they are also displayed as a currency, but they are stored internally as a currency data type, which is similar to the decimal number, but in reality is not a floating point, is a fixed point decimal number. If you change the data type to decimal number, an automatic conversion is generated for the column, and the column is displayed using the format that you choose. So you can display a decimal number using the same currency format. What changes is the internal representation of this number in memory. Every time you change the data type of a column, you obtain an automatic conversion of the data existing in the table. If you change the data type to integer number, to whole number like in this case, you are going to lose the decimal part of the number. In fact, if now you convert the data type back to a decimal number, you no longer see the decimal value and you keep the sales amount equal to 5 in the rows that you see in the screen. At this point, if you want to recover the original value, you have to refresh the entire table, getting the data from the original data source again. At this point, storing the data in a decimal number, you will still see the original value of sales amount that contains also the decimal point. Converting to a currency still doesn't lose any precision because you still have the decimal values in both the formats. As you have seen, we have three data types that we can use to store numbers in Power Pivot. You have the decimal number that corresponds to a floating point. You have the currency, which corresponds to a fixed point, and you have the whole number, which is an integer value. Another interesting data type in Power Pivot is the date data type. It is used to store both dates and time, and in fact you can display it in several ways. You can display only the date, only the time, or both date and time. changing the visualization does not change the content of the column. In fact, if you choose the date and then you choose the time, you never lose the original date, which you can restore at any time. It's useful to know how the date data type is stored internally in Power Pivot. In order to understand how it works, we remove all the columns that are not the order date, and we will use a few calculated columns in order to make a few experiments. If you change the data type of a date column to a decimal number, you see a number that represents the number of days that elapsed since December 30, 1899. This number is a number of day, and the decimal part is the fraction of the day. So you can convert from date to number and from number to date at any time, and you will never lose any information by doing that. So we can manipulate a date-time data type by using the same operation that we can apply on a decimal number. For example, if we remove the decimal part from a number, we remove the date from a date time, and so we fundamentally move the number to the midnight. For example, if you extract the integer part from a date, you obtain the number of days elapsed since December 30, 1899. And you can convert the result of this trunc function into a date data type, and you then can format this data type as you want, for example by showing only the date. At the same time, we can generate a column containing a time using the time function that requests hour, minute and second as arguments. You might wonder why you see this date and time in this new calculated column. And the reason is that the result of time is in reality a decimal number that corresponds to 0.25, which is a quarter. In fact, we requested 6 AM, that corresponds to 1/4 of a day. And this is the reason why when you format by using just the hour, you see exactly 6 AM. Now, what happens if we sum two values and convert the result into a date time? For example, we can get the value of the order date column in the sales table and sum to this value 0.25 that we know correspond to 6 AM. The result is 6 AM on a specific day, the same day we have in calculated column 1. So we can use the same operations, sum, subtraction, that you have on decimal number, and you can apply this calculation to dates. For example, if you sum 1, you obtain the day after, because you sum exactly 24 hours to an existing date. And this is an interesting thing to know in order to create different calculations over date and time. However, you will see that there are specific DAX functions to manipulate date and time, and these functions are more readable than a direct manipulation using the arithmetic with the numbers.